Welcome back, students. Welcome to my change of base formula. That's what we're going to learn about. It's a very, very, very useful formula for doing logarithms on the calculator because this is the formula that allows you to change from one base logarithm to a different base logarithm, which obviously base 10, your common logarithm, the one that we talked about in the last video, is a different base from most of the problems that we've been working so far. So if we want to know how to do those problems in the calculator, we need to pay very close attention to this change of base formula. So let's jump in. What does it look like? It looks like this, which I know it looks a little confusing at first. It looks a little daunting, but it is not as bad as it seems. So how would I read this? What does this say to me? It says log base A of n is equal to log base b of n over log base b of a. All right, that doesn't really help us, right? But let's like kind of trace our letters. What do we have in here? Where are our variables? Well, we've got an a and we've got an n on this side. A is our base, n is just our number, our argument, as we would call it. So we have a is the base, n is the argument, and on this side, the base, what was the base over here, is on the bottom, and what was the argument over here is on the top. And that's going to be how you're going to remember this formula. Over on this side, a is on the bottom, n is on the top. Over on this side, a is on the bottom, n is on the top, okay? But Mr. Johnson, I hear you ask, what about this b? Where did this b come from? What am I going to put in for b when I'm using this formula? Well, the answer to that, my friends, is anything your heart desires. This b can be anything as long as it is the same on the top and the bottom. In the numerator and denominator, as long as the b is the same number, you can make it 2, you can make it 10, you can make it 20 trillion. Doesn't matter as long as it's the same, okay? Most commonly, especially for our homework, it's just going to be 10. We're just going to be using common logs here, okay? So what does this look like practically speaking if I were going to apply this, right? So let's say that I've got some log, let's say log base 3 of 11, and I want this in common logs, okay? I want a different base. I don't like base 3. Base 3 is hard to work with. My calculator doesn't have the button, whatever. So what we're going to do is this 11 is going to go to the top, this 3 is going to go to the bottom, right? Log base 10 of 11, because it's on the top, and then on the bottom, log base 10 of 3. Where'd the 10 come from? I made it up. Doesn't matter. This could be anything as long as it's the same on the top and the bottom. It could be 72, 72, whatever. The reason I use it, I'm using 10, is because the calculator has common log buttons. So on the calculator, it would look something like this. There would be no 10 there. It would just be log 11 over log 3. All right, and that would be easy to solve. We know it. We can punch in the calculator log 11 divided by log 3, and that will give us our answer. Okay, and that's all there is to it. Just got to remember, keep the base on the bottom, keep the argument on the top, and you're done. Okay, so I'm gonna do a couple of example problems, and you guys are, I'm gonna encourage you guys to work them on your own as soon as I pull them up. So let me just take this. Let's get rid of this. Okay, that little speck, I didn't quite grab you. Okay, let's take a look at these example problems. All right, now what I want you guys to do is I want you to pause this video and see if you can put these into common logarithms using this change of base formula. See if you can do it on your own. It shouldn't be too challenging. And heck, once you're done that, once you put it in common logarithms, go ahead and simplify it and plug it into your calculator. Round it to the nearest 10,000th. I should say thousandth, not 10,000, because we're not dealing with numbers that high. Well, I guess technically speaking we are, because they're logarithms, but you know what I mean. All right, so go ahead and pause your video and see if you can do it. All right, I'm sure many of you did not pause your video, but there's no way for me to check. But anyway, I'm gonna walk you through the way that this works. Okay, so common logarithms, easy peasy, lemon squeezy. So we're gonna put a log on the top, we're gonna put a log on the bottom, and we're just gonna keep the 3 on the bottom and the 20 on the top. 20 and 3. All right, so that is common log. This thing expressing common logs, we're done. Okay, but if we want to actually solve this, I'm gonna pull up my calculator here. I'm gonna clear all this stuff out. Okay, so I'm just gonna go ahead and plug it in. So first thing on the top, I got log 20. So I'm gonna 20 log divided by 3 log. Okay, and so the answer to the nearest 10,000th is let's see, 2.7268. So 2.7268, and that's it. That's the answer. All right. This one's going to be just as easy. So on the top we've got log 8 because that's the argument. On the bottom we've got log 6 because that's the base. Just remember your base is on bottom. And then we'll just plug it into the calculator and go. Right? So log 8 divided by log 6 equals 1.1605. But remember, we round 5s up, so it's 1.1606. So 1.1606, and there's your answer. All right. So I think that's good. I think that you guys know how to use the base formula now. I'm going to stop this video, but I'm going to create another video for those of you who are interested. I'm going to prove this thing. I'm going to show you guys why it works. I just showed you how it works. Now I'm going to show you why it works. So if you are a math enthusiast or you don't like to just blindly follow and plug in formulas and stuff, I encourage you to join me in the next video where I prove that this formula is true. Okay? Anyway, I hope to see you there. Good luck with your homework.